alignment and proper fit between two mating surfaces in angular contact applications. The process involves carefully removal of material from the mating surface to achieve the desired angle and surface finish. To check the angle of the mating surface, a sine bar is commonly used. A sine bar is a precision measuring tool consisting of a hardened steel bar with accurately ground parallel surfaces. It is used in conjunction with a dial indicator or a height gauge to measure the angle of the scraping surface. At the end of this exercise, you shall be able to file to flat and square, mark as per drawing and punch witness marks, prepare part 1 and part 2 as per drawing by scraping, and check angle with sine bar and dial indicator.
This topic involves the use of several tools and equipment. Here are the main tools commonly used. Scraper. This device used to produce key slots, oil lines and parallel surfaces. Sine bar. This equipment used to measure parallelism and angularity of surface with supporting tool called dial indicator. Dial indicator. It is the high-precision device used to measure surface, parallelism, waviness and angularity with highly accuracy. Height gauge. It is a special precision equipment used to measure the vertical height of the job by using beam, base and scrapes. While on measuring, the gauge is placed on the main surface block used to give datum to the base. Precision parallels or gauge blocks. In these, accurate gauge blocks are used as joining equipments while measuring of angle and height of the job, etc. While working, a special property ringing is used to align the blocks. Vise or fixture. This type of tools are used to hold the job rigidly while the time of machining and some other fitting and filing operations. Cleaning and deburring tools. These are the primary tools used in the process of scraping the external angular mating surface and checking the angle with the sine bar. Proper selection, calibration, and handling of these tools are crucial to achieving precise and reliable results, and also these type of tools used to play major role to measure the surface finish and accuracy. Check the raw material for its size. File to flatness and squareness to overall size. Mark dimensional lines as per drawing and punch witness marks. Cut off the material into two pieces, part 1 and part 2, by hacksawing as shown in figure 1. File part 1 to size and shape, maintaining the dimensional accuracy plus or minus 0.02 millimeters. Check the dimensions with vernier caliper. Check the angle 19 degrees 17 minutes with vernier bevel protractor. Similarly, file part to size and shape and also to angle 19 degrees 17 minutes. Apply Prussian blue evenly on the surface plate to check high spot on angular surfaces. Place part 1 and part 2 angular surfaces on surface plate and move gently. Take the job from the surface plate and notice the high spot, Prussian blue spotted marks, on angular surfaces. Hold the job in a bench vise, scrap and remove the high spots with a flat scraper. Repeat the process until the Prussian blue cover the entire angular surfaces of part 1. Similarly, scrape part to and maintain the angular surface without high spot and angle 19 degrees 17. Clean the surface plate, sign bar and slip gauge with soft cloth. Select the slip gauge to the height of 33.0 to 4 mm. Set the part 1 in sign bar and clamp it properly. Fix the dial test indicator in the stand. Set the dial test indicator plunger on the angular surface of the jaw. Set the dial test indicator pointer in 0 position. Bring the slip gauges under the sign bar roller. Move the dial test indicator from one end to other end and check the parallelism of the angular surface. If the dial test indicator pointer does not move plus or minus side and stand still in 0 position means there is no deviation in the angular surface of jaw. Instead of that, the dial test indicator pointer moves plus or minus side means there is a deviation in the angular surface of the jaw. If you notice any deviation, correct the parallelism of the surface of the jaw by using suitable slip gauge and calculate the actual angle. Dismantle the setting, clean all the instruments, and keep it in proper place. Make part 1 and part 2 angular surface and apply thin coating of oil and preserve it for evaluation. Tan theta is equal to opposite side divide by adjacent side is equal to 35 divide by 100 is equal to 0.35. Hence theta 19 degrees 17 minute 20 seconds. As per trigonometric table, tan theta is equal to 0.35. Theta is equal to tan inverse 0.35. Theta is equal to 19 degrees 17 minute 20 seconds.
The topic revolves around scrapping an external angular mating surface and checking the angle using a sign bar. Scrapping the surface involves the removal of material to achieve a precise angle. This process involves several steps including cleaning the surface, setting up the sign bar on a flat reference plane, mounting the workpiece and positioning a dial indicator to measure the deviations. The angle is adjusted by using shims or other means to achieve the desired angle on the workplace. The scrapping process is carried out using a scraper tool, applying even pressure and making control strokes. The angle is periodically checked using a precision level or an angle measurement tool. The sign bar serves as a reference surface and aids in setting up the workpiece of the desired angle. It helps ensure accurate measurements and adjustments during the process. The dial indicator helps in measuring deviations from the desired angle. Once the desired angle is achieved, the surface is cleaned to remove any debris and the angle is rechecked for accuracy. So, the topic emphasizes the steps involved in scrapping an angular mating surface, the use of a sign bar for angle measurement, and the importance of precision in achieving the desired angle for proper mating of component. I hope you have understood all the concepts and exercises. In our next video, we will bring you another wonderful concept. Till then, take care.
Hi, my name is Deepthi. Today we are going to learn about flaring of pipes and pipe joints. Flaring is the process of creating a flared end on a pipe or pipe joint. This is usually done by heating the end of the pipe and then shaping it with a tool. The flared end helps to create a seal when the pipe is connected to another pipe or fitting. Flaring is used in a variety of industries including plumbing, oil and gas, mining, and steam systems. Come, let's go into the video.
At the end of this demonstration, you will be able to cut a GI pipe using a pipe cutter, remove burrs using a pipe reamer, flare the end pipe, join flare nut with flare fitting and test it. Tools required: adjustable wrench 200 mm, valve key 6 mm, cylinder valve opener, pressure gauge with adapter, cylinder with pressure, water pump pliers, pipe cutter, hacksaw with blade, tri-square, punch tool. Equipment required: flaring block with yoke, flat file smooth 200 mm, pipe vise. Materials required: GI pipe, flare nut to suit the pipe, thread seal tape, soap solution with stirrer, a small quantity of oil. Before starting job, there are some preliminary checks to be made. Those are as follows. Check the material size and its conditions. File and check that end of the pipe must be exactly perpendicular to the pipe axis. Slightly deburr inside and outside edge of the pipe. Clean the pipe throughout before installing a flaring block. Insert and fix the pipe into flaring block selected hole. Note: examine the pipe flaring tool before starting to flare the end of a pipe. Tighten the nuts at each end of the flaring block properly. Position the pipe end to at least 3.3 mm above the top of the flaring block. Note: this distance is calculated as pipe diameter divided by 3, in this case 12 mm divided by 3, is equal to 4.0 mm. Place the yoke, flaring tool, to the flaring block. Note: insert the flaring nut before flaring. Oil the cone and slowly screw it into the end of the pipe. The end of the pipe will be formed into a flare. Note: do not over-tighten the screws. Unscrew and remove the flared pipe from the block. Check the flare end for cracks. Note: because the cone was screwed down too quickly, flare is cracked. Make sure that the flare is in correct size. If any crack or too loose while fitting flare nut, cut off the flare and start again as per above instruction until the flare is in correct size for the flare nut. Next, we are going to make flare joints and test them with flare fittings. Flaring. Brake line pipes, fuel pipelines, air conditioner pipelines are sometimes joined to fittings by making a flared connection. The end of the pipe is opened out to form a cone. Always place the special flare nut on the pipe first before flaring. Examine the pipe flaring tool. Make sure that you understand how it works before starting to flare the end of a pipe. Make sure that the end of the pipe is free of rough edges before flaring. Place the pipe in the tool. Make sure that you have placed the flare nut on the pipe. Choose the correct size hole in the flaring tool to fit the pipe. There are 5 holes to fit different sizes of pipe. If the pipe is 1 by 4 inch, 6 mm in diameter, position the pipe so that the end is at least 2 mm above the top of the flaring block. This distance is calculated as pipe diameter divided by 3. In this case, 6 mm divided by 3 is equal to 2 mm. Tighten the nuts at each end of the flaring block. Fit the yoke to the flaring block. Note: repeat the steps to the various sizes of GI pipe. Joining with flare fittings. Put thread seal tape on the thread. Push back the flare nut and place the flared pipe on the fitting. Then, tighten the flare nut using adjustable wrench or suitable double-end spanner. Tighten the one end of the pipe to the cylinder with the flare nut. Connect a pressure gauge at the other end of the tube with flare nut. Note: do not give more pressure while tightening, since this will spoil flare. Make sure that they should not be loose in the pipe. Observation Table 2. After joining the pipe firmly, open the cylinder valve with the help of valve key or ratchet. Note: the pressure will be shown in the pressure gauge. Then close the cylinder valve. Major leaks will make noise, and that needs the nut to be tightened. If there is no leak, the pressure in the pressure gauge will remain constant. If it decreases, check the joints with soap solution foam. Leak will bubble, then tight the joints. If it stands still, then there is no leak. Now, let's have a look at handling of pipe flaring and cutting tools. Measure the required length of pipe and mark it with chalk. Keep the pipe in the pipe vise and tighten it. Fit the pipe cutter on the GI pipe on the scribed line and tighten the jacking screw so that the cutting wheel is touching the pipe. Note: ensure that the pipe is kept horizontal and parallel to the serrations such that the marking is visible at the top. Rotate 1 or 2 turns to ensure that the cutting wheel is sitting exactly on the scribed line at 90 degrees to the pipe. Rotate the pipe cutter around the pipe. After 2 or 3 turns, use the jacking screw to apply pressure on the cutting wheel. Keep rotating the pipe cutter around the pipe. Increase the pressure to the cutter by repeating the cycle until the pipe is cut through. Support the pipe with your left hand so that the free end of the pipe does not fall. Remove burrs using a pipe reamer. Check that the pipe ends are square. Inside edge of the pipe must be slightly deburred. Outside edge of the pipe must be slightly deburred. With this edge as reference, the pipe is marked for bending. Always use pipe bending fixture for proper bending of the pipe. Clean the pipe thoroughly before installing in the machine. Prepare the pipe end for a flare fitting. Flaring with block and punch tool. Pipe which is cleaned off burrs and bent should be selected. The pipe end is held in the flaring unit. Select the appropriate size of flaring unit to suit the pipe. Sleeve and cap nut should be assembled before flaring. The flaring unit is held in a bench vise with the pipe. Correct length of pipe should be projecting for flaring pipe edges should be in line with surface. Using the flaring punch, flare the pipe end. Flaring can also be done by using a compression type flaring tool. Installing a flare fitting. Flared tube is cleaned and the sleeve and cap nut are positioned on the flare. Check the flare angle is suitable to the sleeve angle. Place the flare on the connector end. Confirm the angle is same. Screw the cap nut on the connector thread by hand. Use a suitable spanner and tighten the cap nut until the pipe does not rotate in the joint.
Let's have a recap of what we have learned today. We have learned to cut a GI pipe using a pipe cutter, remove burns using a pipe reamer, flare the end pipe, joint flare nut with flare fitting and test it. Thus, we have learnt about flaring of pipes and pipe joints. Hope you have a clear understanding on this. Do this exercise with the help of your instructor. Hi, my name is Deepthi. In this video, we'll be discussing the cutting and threading of pipe length. This is an important process in the construction of pipe systems, and there are a few things to keep in mind to ensure it's done properly.
At the end of this demonstration, you will be able to mark and cut pipe to length using pipe cutter. Tools required: adjustable wrench 200 mm, valve key 6 mm, cylindrical valve opener, pressure gauge with adapter, cylinder with pressure, GI pipe cutter, pipe vise, equipment required: flaring block with yoke, flat file smooth 200 mm, materials required: GI pipe, flare nut to suit the pipe, wire brush, pipe die set with ratchet, thread cutting oil. Before starting job, there are some preliminary checks to be made. Those are as follows. Hold the GI pipe in pipe vise tightly. Mark the required length as per drawing. Fix the pipe in pipe vise and tighten it to prevent it from rotating. Fix the pipe cutter on the GI pipe. Cut GI pipe for the required length using pipe cutter. Remove burrs using pipe reamer. Check that the pipe ends with tri-square for squareness. Now, we are going to thread GI pipes using die stocks. Select a set of dies and ratchet type die stock. Open the adjustment lever, coincide the 0 setting mark 0 die stock, and then insert the 4 dies according to the number on the dies and die stock respectively. Ensure that the dies sit in the correct position. Note: be sure that the number on the top edge of the die corresponds with the number of the slot into which it is to be placed. Fix the pipe in a pipe vise and tighten to prevent it from rotating. Note: ensure that the projection of the pipe is within 150 to 250 mm from the vise. Open the self-centering pipe guide and slide the stock over the end of the pipe. Adjust the pipe guide for correct sliding, fit, and lock into position. Apply a cutting lubricant to the part which is to be threaded. Note: use lard oil or mineral lard oil when threading GI pipes. Apply a little pressure to the stock and keep the handle at right angle to the pipe axis. When the dies bite into the pipe, stop pushing and continue the rotation by moving the handle up and down. Apply the lubricant to the pipe after the first thread has been cut. Keep rotating the handles clockwise and check the length of the pipe thread. Note: ensure that the length of the thread is sufficient to fit halfway into the socket or coupling. If the die stock and the die stick, turn the stock anti-clockwise to break the chips. Reverse the ratchet knob, ease the handle, and turn the stock anti-clockwise till the stock and dies come out of the pipe. Clean the thread with a wire brush. Form thread until the pipe extends about 1 or 2 threads beyond the end of the stock. Remove the stock and dies by operating the quick release lever and clean off the thread with a wire brush. Check the formation of thread with a standard fitting. Repeat the operation if the thread is too tight by adjusting the dies.
Let's have a recap of what we have learned today. We have learned to mark and cut pipe to length using pipe cutter. Thus, we have learnt about cutting and threading of pipe length. Hope you have a clear understanding on this. Do this exercise with the help of your instructor. Hi, my name is Deepthi. One of the most important aspects of plumbing is the fitting of pipes. This is a process that involves connecting 2 or more pipes together in order to create a system that is able to transport water or other fluids. There are a number of different ways to fit pipes together, and the method that is used will depend on the type of material that the pipes are made from, the size of the pipes, and the type of connection that is required. Today, we are going to learn about fitting of pipes as per sketch, observing conditions used for pipe work.
At the end of this demonstration, you will be able to fix the GI pipes with fittings as per drawing. Tools required: adjustable wrench 200 mm, valve key 6 mm, cylinder valve opener, pressure gauge with adapter, cylinder with pressure, pipe cutter, hacksaw frame with blade, tri-square, pipe die set, water pump plier. Equipment required: flaring block with yoke, flat file smooth 200 mm. Materials required: GI pipe, flare nut to suit the pipe. Before starting job, there are some preliminary checks to be made. Those are as follows. Calculate the length of pipe required based on drawing. Cut the pipes as per the calculated length using pipe cutter or hacksaw. Cut thread at the end of all the pipes using die stock. All the pipes have been measured and has been cut as per the calculated length. Now, let's begin with fitting. Fit T1 to pipe 1 using pipe wrench. Fit the pipe 2 to T1 using pipe wrench after adopting the procedure. Fit elbow 2 to pipe 2 using pipe wrench after adopting the procedure. Fit pipe 3 to elbow 2 using pipe wrench after adopting the procedure. Fit elbow to pipe 3 using pipe wrench after adopting the procedure. Fit pipe 4 to elbow using pipe wrench after adopting the procedure. Fit a socket to pipe 4 using pipe wrench after adopting the procedure. Fit bib cock to socket using pipe wrench after adopting the procedure. Fit pipe 5 to T2 using pipe wrench after adopting the procedure. Fit socket to pipe 5 using pipe wrench after adopting the procedure. Fit bend to socket using pipe wrench after adopting the procedure. Fit socket to bend using pipe wrench after adopting the procedure. Fit pipe 6 to socket using pipe wrench after adopting the procedure. Fit elbow 3 to pipe 6 using pipe wrench after adopting the procedure. Fit pipe 7 and 8 to T3 using pipe wrench after adopting the procedure. Fit socket to pipe 7 and 8 using pipe wrench after adopting the procedure. Fit bib cock to sockets using pipe wrench after adopting the procedure. Remove any excess hem, string or sealing tape after completing the joints using hacksaw blade or a blow lamp. Assemble pipe with standard fittings. Now we are going to assemble the pipe and pipe fittings. Hold the pipe number 2 in a pipe vise. Wind the hem packing or cotton thread material on the external threads of the pipe. Apply sealing compound over the pipe threads. Fit T2 to pipe number 2 and tighten it using a pipe wrench. Note: wind the hem packing to external threads of all the pipes in standard fittings and apply sealing compound over the threads before joining with the other one. Fit pipe number 3 with elbow 2. Fit elbow 1 to pipe number 3. Fit elbow 1 to pipe number 4. Fit a socket to pipe number 4. Fit bibcock to socket. Fit pipe number 5 to T2. Fit pipe number 5 to socket. Fit socket to elbow 2 on both ends. Fit socket to pipe number 6. Fit T3 to pipe number 6, 7, 8. Fit socket to pipe number 7. Fit socket to pipe number 8. Assembling elbow with pipe. Now we have successfully completed the assembling.
Let's have a recap of what we have learned today. We have learned to fix the GI pipes with fittings as per drawing. Thus, we have learnt about fitting of pipes as per sketch observing conditions used for pipe work. Hope you have a clear understanding on this. Do this exercise with the help of your instructor. Your instructor. Hi, my name is Deepthi. Bending of pipes, cold and hot, is a process that is used to change the shape of a pipe. This can be done for a variety of reasons, such as to fit a new shape or to make the pipe easier to transport. There are two main methods of bending pipes, cold and hot. Cold bending is done at room temperature, while hot bending is done using heat. Today, we are going to learn how to bend pipes using hot and cold method.
At the end of this demonstration, you will be able to bend GI pipe by cold method as per template on a pipe bending machine. Bend GI pipe by heating and match with template. Tools required: pipe wrench, tape measure, pipe cutter, hacksaw, pipe bender, tri-square, steel rule, soft hammer. Equipment required: pipe stand, hammer. Materials required: pipes, bending spring. The first method we are going to try is cold bending method. Cold bending of pipes is a process where a pipe is bent using cold temperatures. This can be done using either a cold bending machine or by putting the pipe in a freezer. The advantage of cold bending is that it can be done without having to heat the pipe, which can damage it. Cold bending also allows for more precise bends to be made. The advantage of cold bending is that it can be done without having to heat the pipe, which can damage it. File the pipe ends and check up its squareness. Check the inside dia of the pipe by using steel rule. Please change the reading from inside diameter from 10 cm. Measure the length of the pipe as per drawing.
R is equal to radius of bend. Theta is equal to angle of bend. L is equal to length of curved portion. Then L is equal to pi into d into theta divided by 360. L is equal to total length is equal to L1 plus L plus L2.
Mark off the beginning and the end of the bend from the center line. Select the standard former to suit the size of the pipe. Fix the bending machine in a bench vise and ensure it is tightened properly. Locate the tube stop bar at the required position. Set the roller on the bending arm by adjusting the screw and lock nut. Bend the pipe by pulling the bending arm towards your body. The sleeve bends the pipe round the former as the bending arm is pulled. The backstop holds the tails end of the pipe in position. Check the bend for squareness, use a set square. Check level of former and first leg 90-degree bend with spirit level by placing spirit levels. Check the angle of bend and radius using standard template. Bending 120-degree by hydraulic bending machine. Fit the pipe former onto the cylindrical arm. Place the pipe between the forming head plates and against the former. Support the pipe and fit dollies or rollers between the upper and lower plates of the forming head. Locate them in position by inserting pins through the plates and the dollies. Close the pressure release valve on the pump body, then start pumping to push the former against the pipe. Turn the pressure release valve anti-clockwise to release the pressure in the hydraulic cylinder. When the arm has moved back about 6 mm to 10 mm, close the pressure release valve to hold the ram steady. Check both bends 90-degree and 120-degree by placing pipe on the layout. The next method we are going to see is hot bending method. Hot bending of pipes is a process in which a pipe is heated and then bent to a desired shape. This process is often used to create custom pipes for a specific application. The pipe is first heated to a temperature that is above its recrystallization temperature. This temperature is usually between 800 and 900 degrees Fahrenheit. The pipe is then placed in a jig or fixture that will hold it in the desired shape. File the pipe end square. Remove burrs. Calculate the length of pipe.
If D is equal to diameter of bend, theta is equal to angle of bend, L is equal to length of curved portion, then L is equal to pi into D into theta divided by 360. If OA is equal to inner radius of bend, R, AB is equal to radius of pipe, R, OB is equal to radius of bend, R plus R, then L is equal to R plus R into Q into 0.01745. Total length of pipe is equal to L1 plus L2 plus L.
Measure and mark off the center of the bend, beginning and end of the bend from the center line. Plug one end of the pipe with a wooden peg. Measure the inside diameter of the pipe and select two suitable wooden pegs for the pipe. Fill the pipe with clean, dry and fine sand. Compress the sand by tapping the pipe up and down with a soft hammer and plug the end. Ensure that the entire pipe is filled with sand. Clamp one end of the pipe in a vise and protect the clamped portion of the pipe with lead or copper shims. Heat the area to be bent with oxyacetylene torch evenly until it glows dull red. The bent area should not be overheated. Pull down the pipe gently in the direction of the bend. Take short pulls until the correct bend angle is reached. Check the bend radius with a template. Apply heat throughout the whole operation and overbend slightly and straighten out the final bend. Remove one end of the plug. Note: ensure that the pipe is cooled before removing the plug. Remove the sand by tapping the pipe gently with a hammer.
Let's have a recap of what we have learned today. We have learned to bend GI pipe by coil method as per template on a pipe bending machine. Bend GI pipe by heating and match with template. Thus, we have learned how to bend pipes using hot and cold method. Hope you have a clear understanding on this. Do this exercise with the help of your instructor. Hi, my name is Deepthi. A globe valve is a shut-off and regulating valve used for controlling the flow of liquid or gas in a pipeline. Sluice valves are used to control the flow of water in irrigation ditches, canals, and other water conducts. Stopcocks are used to control the flow of water in household plumbing. Today, we are going to learn about how to dismantling and assembling of globe valves, sluice valves, and stopcock.
At the end of this demonstration, you will be able to dismantle and assemble a globe valve, dismantle and reassemble a sluice valve, gate valve, dismantle and assemble a stopcock. Tools required: spanner, screwdriver, file, hacksaw, hammer, pipe wrench, pipe die set, adjustable spanner, pliers, soft hammer. Equipment required: pipe vise, bench vise, oil can. Materials required: stopcock, union, thread seal material. Now, let's have a look at the parts in the following components. First, we'll look at the parts of globe valve. Globe valve. Hand wheel or key. Shaft of spindle. Packing nut, gland nut. Stuffing box with packing. Bonnet. Thread portion of the spindle. Metal valve or metal disc with rubber washer. Inlet. Outlet. Valve seat. Globe-shaped body. Now, we'll look at the parts of sluice or gate valve. Sluice or gate valve. Hand wheel or key. Shaft, spindle. Packing nut, gland nut. Stuffing box with packing. Bonnet. Screw adjustment. Seat and disc gate. Flow of water. Now we are going to see the dismantling and assembling.
Shut off the water by closing the main valve. Close the gate valve and remove the wheel nut with a spanner.
Remove the gland nut from the bonnet. Clean out the old packing in the stuffing box. Remove the bonnet with a spindle from the body and clean all the parts. Coil the asbestos rope, smear it with water pump grease and push it down with a screwdriver. Assemble the spindle gate to the bonnet. Assemble the gland nut, hand wheel and tighten the hand wheel nut.
Open the gate valve and tighten the gland nut until the packing is compressed sufficiently to stop the water escaping from the gland nut.
Note: do not use the gate valve to regulate the flow. It should be either in fully opened or fully closed condition. Clean the pipe joints free from rust and dirt. Loosen the union and separate the pipe joint. Loosen and remove the pipe nipple from stopcock. Loosen and remove the stopcock from the pipe joint. Dismantle the stopcock parts one by one systematically. Clean all the parts properly. Check the parts of thread. If worn out, replace with correct one. If it is in good condition, clean it properly and use it. Check the washer, whether it is damaged or in good condition. If damaged, change the washer. Reassemble the parts to ensure in good condition. While assembling the dismantled parts, last one should fit first and vice versa sequence. If the stopcock is in damaged condition, change it with new stopcock. Fit the stopcock to one end in lengthy pipe in the dismantled place pipe joint properly. Fix the pipe nipple to other end of stopcock properly. Next, fit the union with pipe nipple properly. Apply pressure and test the pipe joints and stopcock. Check for leakage, if any, to ensure proper working. Note: the arrow embossed on stopcock is to be in the direction of flow of water. Check the direction of arrow before fitting stopcock. Don't over-tighten stopcock and other pipe fittings. Use proper tools for dismantling and assembling pipe fittings.
Let's have a recap of what we have learned today. We have learned to dismantle and assemble a globe valve, dismantle and reassemble a sluice valve or a gate valve, dismantle and assemble a stopcock. Thus, we have learnt how to dismantle and assemble globe valves, sluice valves and stopcocks. Hope you have a clear understanding on this. Do this exercise with the help of your instructor.
Hello and welcome to DigiShala. I am Dr. Priyanka Sharma, working as Professor and Head IT and Telecommunication Department, Raksha Shakti University, Ahmedabad, Gujarat. Today, I will be talking on cyber threats in digital payments. Now, knowledge of digital payment and its threat is need of the hour due to Digital India revolution. As recent demonetization drive, we have moved from cash to less cash and cashless economy, and the success of this